yet another video on our channel Euclid Mathematics. We have started lecture series on EMHT CET, JEE Mains plus Advanced and other competitive exam too. As I observe, most of the students they are not capable to pay the fees of bigger classes. So now I decided to start free class for EMHT CET Mathematics, JEE Mathematics and all mathematics related exam. In my live class, I will go through one-on-one doubt solving. I will help the student to clear their doubts and I will teach them a new topic in easy way. And it's my request, those who are listening to me and those who are seeking help related to math and their doubts, where we will go through detailed discussion and understanding of different topics in mathematics, as we will go through proper planning and a proper topic wise understanding of the syllabus. Now, okay, in my today's video, I will explain to you all one of the previous year question from MST CET Mathematics, which is solely based on differentiation, monotonic function and minima maxima, okay? So monotonic function, minima maxima. For that, we have to find the minimum value for our given function, okay? So now let's get start our today's lecture. So here in my question number 43, we have given question, the minimum value of a function f of x, which is equal to x log x. Okay, so we want the minimum value for our function, and function it is given x log x, logarithmic function is there, and we have to find out the minimum value, okay, and the minimum value which is given in the form of exponential term, okay. So we can see it here, function is in the form of logarithmic and there minimum value in the form of exponential. So logarithmic and exponential terms are quite exact opposite to each other, so it is easier to get the answer, okay. So here four options are given. First, negative of 1 by e, second negative of v, third 1 by e, and fourth only e, okay. So we have to figure it out which one of the option is correct, okay. Now let's get start our today's solution. I will explain to you all how the solution look like. So here in our question number 43, we have given function x multiplied by log x. For finding the value for minima and maxima, we need to know one or two standard result only, okay, which is quite easy. That for finding the value for maxima minima, we have to just use the differentiation of our function at some constant point, okay. So our first result, it says that for local maxima at x which is equal to c. So if you wanted to find out the value for maxima, okay, maxima or local maxima, don't get confused, both words are having same meaning, okay. So maxima or local maxima, both are equal. So for finding the value for local maxima at some constant point, we find first of all it's a differentiation, and for that particular constant point we show that it is a 0, okay, and their double differentiation with that constant point, it is smaller than 0, okay, for local maxima. And for minima we have to go for exact opposite direction, okay. So differentiation at that constant point, it will remain same, but the double differentiation at that constant point, it will be strictly bigger than 0, okay. That means 0 is not involved here, okay, and it is not here for their double differentiation, okay. And if their double differentiation it comes 0, okay, their double differentiation it comes 0, then we say that test is a fail, okay, for that particular constant point. But always remember, we need first of all for that particular constant point, this differentiation is 0, okay, here it is 0, here it is 0, and here it is 0. But for next condition, okay, next condition we need a differentiation smaller 0 for maxima, minima bigger 0, and test fail equal to 0, okay. So need to remember all these three results. Now in our question, we want the value for minima from our f of x, okay. From our f of x, we want the value for minima. So local minima at x is equal to c. We first of all find out f dash of x, and we put that some constant point there, and f double dash of x we use double, it's bigger than 0, okay. So this is the condition for local minima. Let's apply this condition to our example and let's figure it out, our solution. Okay, now see here, for minimum value, so what we do, we put f dash of x or f dash of c for that particular constant point is 0, okay. So for f dash of x which is equal to 0, so what we do, we have to find out first of all differentiation of our given function. So f dash of x, here we have two function in the multiplicand form. So apply by part rule here. By part rule for differentiation, it says that first function as it is differentiation of a second plus second function as it is differentiation of first. So this is the by part rule of a differential equation. So apply as it is here and put f dash of x is 0. That means f dash of x here, first function as it is, okay, x as it is differentiation of a log of x. So x as it is a differentiation of a log of x which is a 1 upon x. So x will get cancelled, okay? Because x is coming denominator and as well as numerator. So we can cancel denominator numerator here. So we'll get the 1 as the first part plus second function as it is, log x as it is, differentiation of a first function x with respect to x, it comes 1, okay? So we no need to write that one here. So f dash of x which is equal to 1 plus log x. Now our second condition, it says that we have to use f dash of that x is equal to 0 for some particular constant point, okay? So put f dash of x is a 0, so that means f dash of x is equal to 1 plus log x which is a 0. Why we have to use? Because of that we don't know the value for x. So for finding the this particular value of x, we have to put f dash of x 0 and find out the value for x, okay? So if this is equal to 0, that means log of x which is equal to negative 1. And we want the value for x, okay? For finding the value of x, try to remove that log, okay? Once we get rid of that log, it's easier to get the value for x. And we all know that when we wanted to remove the log, so we have to apply the exponential term there, okay? So apply exponential term here and other side too. So exponential term of a log x which is equal to exponential term to the power minus 1, okay? So e to the power log x which is equal to e to the power minus 1. So I applied log exponential term both side, and we know that logarithmic term and exponential term, these two are exactly opposite to each other. So they cancel each other whenever they come to close each. Okay, so log and exponential term will get cancelled, x will remain same, and e to the power minus 1 it is here, okay? So x, I got the value for x is e to the power minus 1, okay? Now we have second condition too. So we got the constant point. Here we see c as a constant point here, x is equal to c. So that is the exact value for c, we found it here, okay? X which is equal to e to the power minus 1, okay? So x which is equal to e to the power minus 1 here, we got the value for constant c. Now apply the second condition, f double dash of a c which is a strictly bigger 0. And now check it out whether it is bigger 0 or not. So we have to apply x to the power x which is equal to the power minus 1, okay, in our result. Okay, so first of all find out f double dash of x. So f dash of x 1 plus log x, and f double dash of x is a differentiation of 1 with respect to x is a 0, no need to write. Log x has a differentiation 1 upon x, okay? So f double dash of x is 1 upon x. Now what we have second condition, f double dash of a c bigger 0, and the c which is here e to the power minus 1, okay? Now f double dash of a c, that means f double dash of e to the power minus 1, okay, which is equal to 1 upon x, that means 1 upon e to the power minus 1, okay? So when we have term 1 upon e to the power minus 1, their power has a negative 1, okay? When we have term here 1 upon e to the power minus 1, denominator here we have to the power minus 1, when we transfer it to the numerator, its power become positive, okay? So the inverse value here that we learned this result already in our 8, 9, 10 classes, okay? So f double dash of some particular constant point, we got the value e, and we know that e is a 2.7 something having value, okay? E is having some value like a 2 point something. That means this is a positive value, and exponential term is always positive, okay? So exponential term e, it is always positive, so it is strictly bigger 0. That means it represents that f double dash of x, it comes when we apply 0, we got the value for constant, and when we use that constant value to our function, okay, it gives f double dash of a c which is a bigger than 0, okay? So our minimum condition for minimum value or minima, it's satisfied here, okay? And with the value for x which is equal to e to the power minus 1. Now we want the value for f of x at x log x at a minimum stage, okay, at the minima, okay, and minima at a point x is equal to e to the power minus 1. Now what we do, we substitute the value for x which is equal to e to the power minus 1 in our f of x, okay? So f of x which is equal to, what do we have function here, we have function f of x as a x into log x, okay? So put e to the power minus 1 instead of x. So f of e to the power minus 1 which is equal to e to the power minus 1 log of e to the power minus 1. Now substitute all these values here. So here we can see f of e to the power minus 1 which is equal to e to the power minus 1 into log of e to the power minus 1, okay? So we know that e to the power log of e to the power minus 1 log and e to the power minus 1. So here e to the power minus 1 log e to the power minus 1. So when we apply exponential rule for logarithm, okay, and what the exponential rule of a logarithm, it says that whenever we have any term to the power of log, so we take it into the multiplicand of it, okay? So that term comes here. So log of e to the power minus 1, so minus 1 comes here, and the log and e both will get cancelled, okay? So that negative 1, it will be here, okay? And log and e will get cancelled because these are quite exact opposite directions. Okay, so e to the power negative 1 as it is. Okay, so negative 1 into e to the power minus 1. So e to the power minus 1 can be written as 1 upon e, and negative as it is. Okay, so which is the required answer from our question 43. Okay, so it is the required option number A, which is given negative of 1 upon e. See, it is a very easy solution that we need to remember maxima and minima, and we can test fail for some certain constant point. Okay, so this is the only result we have to apply for finding the solution of our example. It's a very easy example, and the solution we can get it in minutes only. Okay, so if you have any doubt, difficulty, let me know in the comment section. I will upload similar video on my channel. Okay, so thank you everyone, thank you for my today's lecture.